Okay, AP Physics C, quiz solutions. Let me just move my computer a little bit closer here so I can read the questions. You guys did pretty well on this. The order of this video might be a little different than what you saw when you took it digitally, but no worries. So number one that I'm going to do is a mass of 3 kilograms is hung from a string wrapped around a large 1.5 kilogram, 0.2 meter radius pulley. String wrapped around it. The mass of this guy, 3.0 kilograms. The pulley has a mass of 1.5 kilograms and a radius of 20 centimeters or 0.20 meters. The magnitude of the acceleration of the system is closest to. All right, so the way you go about this is you apply Newton's second law to each object. So I'll look at the pulley first. All right, what we're interested here is the rotational. The force of tension is causing the rotational motion here. Omega is going to be clockwise. I'm going to say that's the positive direction. I'm going to say this is the positive direction, the object going down. So I have the object going down. I have that same force of tension pulling up on this and its own gravity trying to pull it down. All right, so over here, force of tension equals I alpha. And over here, Fg minus Ft equals Ma. All right, so you know that this must be something less than 9.8. So you know that it can't be 9.8 meters per second squared. Then it becomes, okay, which one is it going to be? Well, the disk, I equals 1/2 mr squared. The acceleration of this, the alpha, is going to be a over r. Now this acceleration going down of this object, that's a rate at which the string's pulling it down. That's going to give it its acceleration as it rotates, right? So we put this all together. We say Ft equals 1/2 mr squared times a over r. Oops, I messed up here. All right, this is Ft times r. I was like, wait a minute, it's not canceling out. I did force. This is got to be torque net. My bad. Out of practice. Torque net equals I alpha. So it's Ft times r. Ft times r. So the r's all cancel. You get Ft must be equal to 1/2 Ma. So put it all together over here. We get little mg minus 1/2 big Ma equals little ma. All right, now we're solving for a, so we bring this over here. We get mg equals 1/2 big M plus little m times a. A equals mg over 1/2 big M plus little m. Or the way we typically will write this, we could have done the old blob method. Acceleration equals m over 1/2 big M plus little m times g. So then we just have to plug in the numbers here, right? Little m is the hanging mass, that's the 3, divided by the sum of the total mass, but we're using the coefficient here. So it's like the little mass proportion of the total mass. 1/2 of 1.5 plus 3. All right, that gives me 0.8. 0.8 times g. So, all right. So this is 0.8 times 9.8 meters per second squared. You get 7.8 meters per second squared. All right, that's the answer there. A couple of you picked 9.8 and 6.7. Not sure how you got there, but that's what it was. All right. Next one uses the same function. I basically ask you to take the integral and ask you to take the derivative of it. So turntable rotates with an angular velocity of omega equals 5t squared minus 4t plus 10. The angular displacement of the system from t equals 0 to t equals 2. Angular displacement is delta theta from 0 to 2 seconds equals the integral of 5t squared minus 4t plus 10 with respect to time from 0 to 2 seconds. Okay, so first take the antiderivative of this, 5t cubed over 3 minus 4t squared over 2 plus 10t. Evaluate it then from 0 to 2. So 0 just is 0, but we plug this in here. So 5 times 2 cubed divided by 3 minus 4 times 2 squared divided by 2 plus 10 times 2 gives us about 25.3 radians. Now, I did make a little bit of a mistake on this when I put it in. I put 26 radians. It said which is the closest to, well, 25.3 is definitely closest to 26 radians. I must have made some sort of rounding error when I figured it out. You know, I made it 26, but anyway, that was the answer. If you put 22 radians, I think I gave you half credit. So you were close. I don't know, maybe some issue there. I don't know what. But anyhow, 26 radians is the closest answer. I should have made it 25 radians. That was my bad. Now the next one says same velocity function. What's the angular acceleration of this system at 2 seconds? All right. So alpha is d omega dt. All right, it's the derivative of this, the velocity function with respect to time. It's a dt. Then we evaluate it at 2 seconds. So first, let's take the derivative of this, which is 10t minus 4. All right, 10t minus 4. And then if I want the alpha at 2 seconds, I have to evaluate this at 2 seconds. So it's 10 times 2 minus 4. 20 minus 4 is 16 radians per second squared. Okay, we'll see if you got that right. One of you picked 20, one of you picked 26. I forget. There's a way to get those answers. I think if you added the 10, you didn't get rid of this. I gave you 26. Somebody fell for that. And then if you just put in, I think if you just put in 2 here, you get 20. Is that right? I forget. But anyways, there we go. Have a good one, everybody. Be good. There's that quiz. Nice and simple, short video. Make sure you know how to do that stuff. I'm sure it'll be on the AP exam in one way or another. All right. See ya.